All right. All right. Something went wrong just now. All right. So seeing Daryl back, Josiah back. Okay, good. All right. So continue with this question here. We want to find the gradient of a line which is parallel to this equation here. Now, before we can do anything with that equation, the first thing we need to do is to write this equation in the form y equal mx plus c. So this equation will be 3y is equal to minus 2x, because we're currently minus 2x on the right hand side, plus 4. So therefore, y is equal to minus 2 over 3x plus 4 over 3, right? So this is the equation of that line. So if that is the equation, it means that my gradient of this line is actually minus 2/3. So the gradient of a line which is parallel to that will be minus 2 over 3, or minus 2/3, right? All right, just hold on 2 minutes here. I just need to get my students to get back in the class. All right, cool. So Danica's back in. All right. Okay, Danica, I can see you there now. Let me see. Yeah, I'm not sure what happened there. All right, so I'll continue there now. All right. So continue with number 4. We have what is the gradient of a line which is perpendicular to the line y equal 5x minus 2. So keep in mind that the general form of any equation of a straight line will be, y equal mx plus c, right? Now, I told you all that for perpendicular lines, when we multiply their gradients, we will get minus 1. So they are telling us that one line has an equation of y equal 5x minus 2, right? So therefore, m is equal to 5. My gradient is 5. Now, if you want the gradient of a line which is perpendicular to it, here's what you need to do. You need to take that gradient, we're going to invert it and put a minus sign in front of it. So when we invert 5, we're going to get 1/5, and we have to put a minus sign in front of it. Now, that disconnection threw me off a little bit here, right? Because I don't want people to get lost or confused by what I'm doing, right? Let me just check something here. I just want to know if Emily and Chad, if you all are back in class. Okay, I'm seeing Emily here. I don't know if Chad got back in. All right, so here's what's going on here. This particular one you have to pay attention to, right? So I did the first one. So the next one here, number 5, you want to find the gradient of a line which is perpendicular to this line, right? So this is 3y equal 12x minus 4. Before I can determine what the gradient is, I need to rearrange this equation. I need to write it in the form y equal mx plus c. In order to do that, I need to divide every single thing by 3 because I need to get rid of this 3 here. So this will become y equal 4x minus 4 over 3. All right? So therefore, my gradient is actually 4. So if I want to know what the gradient of a line, which is perpendicular to this line, what I need to do, I need to invert my gradient. So it's going to be 1 over 4. And I have to put a minus sign in front of it. Right? So the gradient of the line which is perpendicular to this line is minus a quarter. Right? Number 6 now, we have a line here, 2y plus x equal to 7, right? And they want to know the gradient of a line which is perpendicular to this line. So the first thing I need to do is to rearrange this formula. So it'll be 2y is equal to minus x plus 7, and therefore y is equal to minus a half x plus 7 over 2, right? So my gradient of this line here is minus a half. So if I want to know the gradient of a line which is perpendicular to this, what I need to do, I need to invert first of all and put a minus sign in front of it. So this is a half. When I invert a half, I'm going to get 2, right? And I need, so we're starting off with minus a half, right? When I invert that, I'm going to get minus 2. And I need to put a minus sign in front of that. And if I put a minus sign, this will become just 2. So the gradient of the line that they want here is actually 2. All right? Let me, 1 second. mostly because I want to make sure you all get this. If I give you an equation like this, 2y plus 5x equal to 4, right? I want you all to tell me what is the gradient of a line that is perpendicular to this, right? So what is the gradient? Gradient of the line perpendicular to this line, right? So this is the line I have here. I want to know what is the gradient of the line which is perpendicular to that. So I'll give you a few minutes to tell me what that gradient is, right? All right, so see Danica got minus 5 over 2. Del got 4 over 5. Tiana staying, I'm stuck. Um, Jasmine got 2/5. All right. Josiah got minus 5 over 2. All right, let me look at it. So 2y equal 5x plus, 2y plus 5x equal 4. So the first thing we need to do, we need to rearrange this and write it in the form y equal mx plus c, right? So what you need to do, 2y plus 5x equal 4. That's what we're starting off with. So therefore 2y is equal to minus 5x plus 4, right? So therefore y is equal to minus 5 over 2x plus 4 divided by 2 will give me 2, right? So this is my first thing. This is what I need to do first. I need to rearrange my equation so that it looks like this. So my gradient is actually minus 5 over 2. So the question is asking, what is the gradient of the line that is perpendicular to this, right? So here's what we need to do. We're starting off with minus 5 over 2. So the first thing, what I'm telling you to do is invert, right? So if I invert this, it'll become 2 over 5, right? That's what it's going to become. Then the next step is to put a minus sign in front of it. If you put a minus sign in front of it, this minus sign here is going to disappear. So this will become 2 over 5, right? So the gradient of that line is actually 2/5, right? So anybody else hearing me? All right. So those of you getting trouble hearing me, what you can do, the video will be saved, so you can always go back to the video, and the audio will be there. All right. So my answer is actually 2/5, right? So I saw who got that. Jasmine got that. Dell. All right. Okay, cool. Right. So let me give you a next one, because I'm not convinced that you all totally got this. That's all. Give you a next one. All right. So I'm giving you an equation. Let's say we have um, 3x plus 2y equal to 5, right? So 3x plus 2y equal 5. I want you to find the gradient of the line perpendicular to this line, right? So I want the gradient of a line which is perpendicular to this line, right? So let me give you 2 minutes to work that out. All right. right. I'm gonna see if you all put any answers. All right, so I see in lots of people saying 2/3. Let's see if that's correct. So the first thing we need to do, we need to rearrange the equation. So we're starting off with 3x plus 2y equal to 5. So therefore we can write 2y is equal to minus 3x plus 5, right? So therefore y is equal to minus 3 over 2x plus 5. So this here, minus 3 over 2 is the gradient of this line. So the first thing we need to do, I told you we need to invert it. So we're starting off with minus 3 over 2. If we invert that, what we're going to get is minus 2 over 3, right? But the thing is, we need to put a minus sign in front of it. So when you put a minus sign in front of it, your gradient is going to become 2/3, right? So the answer is 2/3. So I see most people seem to have gotten 2/3 this time around, all right? So great. Now, let me just move on to our next question here, right? So let's look at this question. So we have a line that has an equation y equal to 2x minus 5. And they want us to determine the equation of the line which is parallel to L. So L is the line that you're seeing there, but it passes through the point P. So this is the point P here. This is the point P. This is the line L here, this red line, right? And they want us to find the equation of the line that passes through P. So here it is. When you all get a question like this, when students read it, they tend to get confused. But you all need to visualize what is happening. So I have a line L, right? And the equation of that line, they've given us that. And they want us to find the equation of a line which passes through the point P, but is parallel to L. So the line that they're talking about will be a line that does this. This line here. The question is asking us to find the equation of this line, right? I haven't worked it out, but I want you to visually understand what is happening. So you have a line L, but I want to get the equation of a line which is parallel to L, but it passes through P. So here's the thing. So we know the equation of L, right? The equation of y equal 2x minus 5. So we know that the gradient of L is equal to 2, right? That's the gradient of L. Can somebody tell me what is the gradient of the line? Let's call this line that we want to work out. Let's call it L2. What is the gradient of L2? So what is the gradient of L2? So what is the gradient of L2? All right, so Del is saying 2. Tiana is saying 2. Emily is also saying 2, right? Now, the reason why you all are saying 2 is because they are parallel. And parallel lines have the same gradient, right? Great, Jasmine, Josiah. All right. So, if we know the gradient of L is 2, then we already know the gradient of L2. So, gradient of L is equal to 2. Therefore, gradient of L2 is also equal to 2, right? So therefore, the equation of that line that is passing through P has to be y equal to 2x plus c, right? Because you know what the gradient is. The gradient is 2. So we need to figure out what is c. In order to figure out what c is, we need to use the coordinates of P, right? So I think you all know how to read coordinates already. So P, right, is equal to 1, 2, right? That's the coordinate of P. So what we're going to do now, we're going to substitute those values and try to figure out what C is. So when x equal 1, y is equal to 2, right? I'm going to take that information and substitute it into this equation. So therefore 2 is equal to 2 multiplied by 1 plus c, right? So this is really equal to 2 plus c is equal to 2, and therefore c is equal to 2 minus 2, therefore c is equal to 0. So you worked out that c is equal to 0, therefore the equation of that line that they are asking us to find is y equal to 2x. Since c is equal to 0, we're not going to write 2x plus 0, right? So this is the final answer. Y is equal to 2x. All right? So let's all right. Let's look at this one here now. So I have a line L, right? And the equation of the line is a half x minus 1. And they want us to determine the line which is perpendicular to L and passes through the point P. So visually, you all need to understand what's happening. So we have a line L, that's this line here. This line here is L. And they want us to find the equation of a line which passes through the point P, that's this point here, but it is perpendicular to the line L. If it's perpendicular to the line L, this is the line they're talking about here. And remember, when two lines are perpendicular, they meet, but they meet at 90 degrees. All right? So I want to give you all 2 minutes to see if you all can work this one out before I work it out. Okay? So I'll give you 2 minutes here. So I'm waiting for you all to come up with an answer, right? First thing we need to do, we need to figure out what the gradient of that perpendicular line is. That's the first thing we need to do. Then we have to use the point P in order to figure out what my constant is in my equation. All right? Wow, we'll work out these answers quick. So I've seen del has y equal minus 2x minus 5. Jasmine, y equal minus 2x minus 4. Let's see what else. Wait and see. Let me get some more answers. So while you all working on that, I want to get all right. So let's see if anybody else put any answers. All right. So first things first, we know the equation of the line L, right? So the equation of the line L is this: y equal a half x minus 1. So therefore, from this, I can tell that the gradient of this line is equal to a half, right? So you know the gradient of this. So we need, for the line that is passing through P, the perpendicular line, we need to figure out what that gradient is. So remember what I told you all. So if we start off with a half, first thing we need to do is to invert. When we invert a half, we're going to get 2. And we need to put a minus sign in front of it. So you're going to get minus 2. So the gradient of the line perpendicular to L, perpendicular to L, is minus 2, right? So therefore, the equation of that line, which is passing through P, will look like this: y equal minus 2x plus c, right? Now the thing is, we're going to have to use the point P in order to determine what c is. So the point P is minus 3, 2, right? That's the point P. So what that means is that when x equal minus 3, y is equal to 2, right? So I'm going to substitute these two values into that equation. So what I'm going to end up with is 2 is equal to minus 2 multiplied by minus 3 plus c, right? So therefore 2 is equal to minus 2 multiplied by minus 3 gives me 6 plus c. So therefore 6 plus c is equal to 2, right? I'm going to have to move across here. So therefore c is equal to 2 minus 6. So therefore c is equal to minus 4. Alright? C is equal to minus 4. So therefore, my equation, or the answer that I want, is y is equal to minus 2x minus 4. Alright? So the answer is y equal minus 2x minus 4. So I'm seeing who had that. That's Jasmine. Alright, so you need to be careful with how you're doing the calculations, how you're doing your subtractions, right? You need to be careful with that. Alright? So basically what we've been looking at are the types of questions they could bring in the exam. For example, this question here, this is actually from the January 2020 exam, right? They give you a graph. They give you two lines, L1 and L2. L1 is this line here, and L2 is this line here, right? So like I said, this is the January 2020 exam. Um, so they gave us two equations, not equations, they gave us two lines, L1 and L2, and they gave us some information. They said L1 intercepts X and Y axes at 40 and 02 respectively, and L2 intercepts the X axis and the Y axis at those values here, right? They want us to determine the equation of L1. So they want to know what is the equation of this line here, right? So we still have 5 minutes left. So I want you all to work out the equation of L1 for me, right? What is the equation of L1? Let me see if I could make this a little bigger for you guys, right? All right, just now. All right, so Tiana is saying my screen is blurred. All right, so here what I will do, right? We will pause there for this one, right? And what I will do when we come to the next class, I'll work this problem for you all, right? So this is from the May 2020 paper. So for my students who are in class, you have some work to hand up for me right, online, which is this, right? Based on what we did today and what we did last week, you'll have three quizzes to do for me, right? That's the one on finding the gradient of a line, finding the equation of a line, and parallel and perpendicular lines, right? So during the week, I will check and see to make sure you all did it, right? I'll send you the WhatsApp while I'm checking, all right? So you guys take it easy, and sorry about that problem with the stream. I don't know, I'm not sure what went on there. All right. If you need to review the video will be obviously in two parts when you go to my CSEC Maths channel. All right. So you guys take care.